analysis. The topic for the today's session is difference between PERT and CPM and numerical problems on crashing. Difference between PERT and CPM is first PERT. It is probabilistic in nature. There is there is a chances of completing the project is probabilistic in nature, whereas in CPM there is critical path method. It is deterministic in nature. There is that will give the actual duration of the project. Next, PERT usually used in R&D projects, whereas in CPM critical path method used in business and construction projects. PERT is an event-oriented network, whereas CPM is an activity-oriented network. PERT is applicable only for big project, that is big project in the sense if the number of activity is more, then the PERT is applicable, whereas critical path method is applicable for small as well as for big project. PERT is a three-time estimation technique, that is will use optimistic time, most likely time and prismatic time, whereas critical path method it is a single time estimate technique. PERT used for repetitive job. It is for the repetitive job PERT is used, whereas critical path method is used for non-repetitive job. PERT make use of dummy activity for representing the proper sequencing. To represent the proper sequencing in network diagram, dummy activity is required in PERT, whereas in critical path method, it is not necessary use the dummy activity. There is no much significance of using dummy activity. In PERT, it doesn't usually consider the cost of the project. That is, in PERT technique, the cost is not a consider, whereas in critical path method, it deals with the cost of the project schedule and their minimization. That is, this critical path method will deals with the cost of the project. It is in minimizing the cost of the project. These are the difference between PERT and CPM. Let us go for the crashing of project network. The aspect of project planning in which the project duration is planned to be reduced is called project crashing. In simple terms, project crashing is nothing but reducing the activity to minimum duration of time in such a way that total project duration and the cost of the project should be minimized or reduced. Then we call it as project crashing. Terms related to project cost analysis is first direct cost, the cost which is dependent upon the amount of resource in the execution of individual
కొంచెం లేట్
activity.
అయ్యేసుకోండి అదలా లేట్ అవ్వరా కొంచెం రైట్
Direct cost, the cost which is dependent upon the amount of resource in the execution of individual activity. Example, manpower, material, machine, etc. These are all the direct cost. Next, indirect cost, the cost associated with overhead expenses, administration, executive service, etc. is this is calculated based on duration of the project. Optimum duration. Duration which result the minimum total cost is known as optimum duration. There is a minimum total cost is nothing but an optimum duration. The next normal cost, it is denoted by CN. Cost corresponding to the crash time is known as normal cost. There is the cost associated with respect to crash time is known as normal cost. Crash cost denoted by CC. Activity cost corresponding to the crash time is known as crash cost. Next, cost slope. The slope indicating the increase in cost per unit reduction in time, and it is given by crash slope equals crash cost minus normal cost divided by normal time minus crash time. That is, crash slope is denoted by Z and is given by Cc minus Cn divided by Tn minus Tc, where Cc is crash cost, Cn normal cost, Tn normal time, Tc crash time. Let us go for the numericals on crashing. A small marketing project consists of job in the table given below, which each job is listed its normal time and a minimum or crash time in days. There is the crash time that given in days, cost in rupees per day of crashing for each job also given. That is the given job II of j, that is starting node and ending node. There are total 6 activity or 6 jobs. It is 1 to 2, 1 to 3, 1 to 4, 2 to 4, 3 to 4 and 4 to 5. And they're given for each job or each activity, they're given the normal duration in days, minimum duration they're given, and cost of crashing rupees per day they're given. That means the last column, cost of crashing, they're given rupees per day. That indicates if you want to reduce the activity 1, 2 for a 1 day, you have to pay rupees of 20. Here, what is the normal project length and the minimum project length? Determine the minimum crashing cost of project. Assume overhead or indirect cost is total rupees 60 per day. It means you need to determine the minimum crashing cost of the project and minimum project length and normal project length. Let us go for the solution. Whatever the table they are given with respect to job and normal duration, you need to copy down the same, and considering the normal duration of the project, the resulting network is given below. That means you need to construct a network diagram. Since there is an activity between 1 and 2, you have to represent it in a node 1, 2, and you have to write a normal duration between the activity 1 and 2 as 9. Then similarly for 1 and 3, that means the node 3 you have to write in front of 2 and below in front of 1 and below 2, and the normal duration is 8. The next we have 1 to 4, you have to write in front of 1, the normal duration is 15, and there is an activity between 2 and 4, you have to represent it by an arrow, and the normal duration is 5. Then similarly for remaining activity, it is for 3 to 4 is 10 and 4 to 5 is 2. Here I have represented in a thin line and a thick line. In network drawing, you have to represent the arrow marker in a thin line. After drawing the network diagram, We have to find the various paths. In this network drawing, there are three paths. This first path, if you consider the 1 to 2, 2 to 4, and 4 to 5, and if you consider the normal duration or total project duration for this path, you will get 9 plus 5 plus 2. It means we will get 9 plus 5 plus 2, we will get 16 days. And we have two more paths. The second path, we have 1, 4, 5. 15 plus 2, we get 17 days. Then we have one more path. This third path, it is 1, 3, 4, 5. If you consider the project duration, we have 8 plus 10 plus 2, we will get 20 days. Out of these three paths, the maximum duration for these three paths is for this path, that is 1, 3, 4, 5. And then you have to represent in a thick line, or you have to draw a double arrow mark that indicates the path 1, 3, 4, 5 is a critical path. After identifying the critical path, that is from the above path, the critical path is 1, 3, 4, 5 because it is having a more duration of time. Then next you have to calculate total cost, and it is given by normal cost of all the activity plus indirect cost into project duration. Normal cost of all the activity in the problem, they are not given. They are given only the normal duration and minimum duration they are given, and hence it is 0 because they are not given in the problem. And indirect cost they are given as 60 rupees, and normal project length is 20. In the question they are given what is the normal project length. The normal project length is 20 days, and hence the project duration is 20. Indirect cost that given in the problem, hence it is 60. The total cost we get rupees 1200. After calculating the total cost, we have these three paths what we identified from the network drawing. Out of these three paths, the critical path is 1 to 3, 3 to 4, and 4 to 5. And hence you have to divide this critical path into critical activities. In this critical path, the critical activities 1 to 3. Here you write 1 to 3. Then next you have 3 to 4. Then next you have 4 to 5. Corresponds to the critical activity 1 to 3. In the problem they are given the crash limit. This crash limit is given by, for the critical activity 1 to 3 is 3. 3 is the difference between normal duration and minimum duration. This value that 1 8 minus 5 that indicates they're given in the column. This 8 is the normal duration, 5 is the minimum duration. 8 minus 5 you get 3. That is the crash limit that indicates the critical activity can crash by 3 days. Then similarly for remaining critical activity, that is for 3 to 4, you have 4. It is 10 minus 10 minus 6, you get 4. Similarly for 4 to 5, you have 1 day. It is 2 minus 1. The normal duration is 2, minimum duration is 1. Difference is 1. There is the critical activity 1 to 3 we can reduce by 3 days. 3 to 4 you can crash by 4 days. 4 to 5 you can crash by 1 day. And respective cost of crashing they are given in the problem. For 1 to 3 it is 25 rupees. For 3 to 4 it is 15. 4 to 5 it is 40. That means if you reduce 1 3 critical activity for 1 day, you have to pay an extra rupees of 25. If you reduce 3 4 critical activity, you have to pay rupees of 15. If you reduce 4 to 5 for 1 day, you have to pay rupees of 40 rupees. Then after writing this table, you have to check from the above table, the least cost of crash is 15. That is for the critical activity 3 to 4. It is out of these three values, the minimum or the least cost of crash is 15. The corresponding critical activity is 3 to 4. Therefore, critical activity T4 crashing is done by 1 day. That is from 20 days to 19 days. Because initially you have 20 days, you have to crash by 1 day for this activity. It will reduce to 19 days and so on. This, the next, we have to construct this table where we have normal duration, crash activity, it is which activity you are going to crash, cost of crashing, and current indirect cost and total cost. Then first you have to fill with respect to the 20 days. That is for normal duration, normal project length, you got it as 20 days. This for the critical activity, you got it as a normal project duration, you got 20 days. Here you write 20. Crash activity from this table, the crash activity is 3 to 4. Means here, if you consider the normal duration as it is 20, if it doesn't crash any activity, say if it doesn't crash any activity, then we have indirect cost there given 20 into 16, it is rupees 1200. Then the total cost will get it as 1200. That is, if it doesn't crash any of these activities, then you have to pay a rupees of 1200. Since there is a possibility of crashing these three activity, out of these three activity, the least cost of crashing is 15, corresponding activity is 3 to 4, and hence will reduce by 1 day, that is from 20 days to 19 days, 20 days to 19 days. Crash activity is 3 to 4. Here you write 3 to 4. In bracket you write 1 day because the maximum limit of 4 you have to reduce by 1 day each. That is from 20 days to 19 days. Cost of crashing for 3 to 4 it is 15. Here you write 15 into 1 day. 15 into 1 day you are reducing it. That equals to 15. Then next, since you have reduced the project duration or normal duration from 20 to 19, and hence you will get 19 into indirect cost that given it is 60 rupees per day. 19 into 60 you get 1140. The next, total cost 1140 plus 15 will get 1155. That means compared to this value 1200, the value is reduced and also the normal duration also reduced. Is the project length, it is project length duration is reduced, cost also reducing, and hence you can proceed further. That is, if you reduce for one more day for the activity 3 to 4, 3 to 4, the possibility is 4 days you can crash. It means you can reduce by 4 days. The next, cost of crashing, the previous year 15, 15 for this activity for 3 to 4, this cost is 15, 15 into 1, then you will get 30. Since you have reduced to 18, then indirect cost will get 18 into 60. The total cost you will get 1080 plus 30, you will get 1110, 1110. That is, the cost is reducing. Then you can proceed further. You can reduce to 17 days. Since the critical crash activity 3 to 4, you can reduce by 4 days. You can reduce by 4 days. You reduce only 2 days, so that you can proceed further by taking the crash activity 3 to 4 by 1 day. Then you will get 30 into 15 into 1 is 45. Since you have reduced the normal duration to 17, you will get 17 into 60, it is 1020. 1020 plus 45, you get 1065. There is the cost is reducing, duration also reducing. At normal duration 17 days, if you check out in these three paths, here 145, the total duration is 17 days. The critical path 1345, which is earlier as 20 days, is reduced to 17 days. Here at 17 days, there are two parallel critical paths. In these two parallel critical paths, we have to reduce by 1 day is for 16. If you compare for these two paths, here 3 to 4 crash activity or critical activity can reduce by 1 day, 1 more day, because the limit is 4 days. We are reduced only 3 days. We can crash by 1 more day. It is 3 to 4, 1 day. For this activity, 1 to 4 and 4 to 5, since 1, 4, 5, the duration is 17 days. This path will also become parallel critical path. Out of this path 1, 4, 5, the critical activities 1 to 4, 4 to 5. In the table, if you check with the cost of crashing for 1 to 4, 1 to 4 and 4 to 5. For 1 to 4, the cost is 30, and for 4 to 5, the cost is 40. The minimum cost is 1 to 4. That is for rupees 30, and hence you have to take 1 to 4. It is for 1 day. Then we will get 45. This previous cost of crashing is 45. For 3 to 4, it is 15. 15 into 1. For 1 to 4, in the given table, in the problem, for 1 to 4, cost of crashing, they are given 30 rupees. So for 30 into 1, we will get 90. Then current indirect cost, since you reduced to 16 days, 16 into 60, we get 960. 960 plus 90, we get 1050. That is the cost further reduced. At 16 days, if you check out in these three paths, all three paths will become parallel critical paths. At this junction, you need to check, is there any common activity? If you check with respect to these three paths, 4, 5, 4, 5, 4, 5. 4, 5 is common activity, so that we can crash 4, 5 by 1 day. That is for 15 days. You can select 4 to 5, 1 day. Here 3 to 4, 3 to 4, the crash limit is 4 days. It is 4 days is over. 1, 2, 3, 4. 4 days is over. There is no further possibility of crashing for 3 to 4. Then next, 4 to 5, since 4 to 5 is common in all these three paths, and then you have to chosen 4 to 5 by 1 day, because you can crash by 1 day. The cost of crashing is 90, previous is 19. For 4 to 5, in the problem they are given, cost of crashing is 40. Cost of crashing in the problem they are given for 4 to 5 is 40. 40 into 1 will get 130. Then next, indirect cost 15 into 60. We are reducing by 15 days. Therefore, 15 into 60, we get 900. Then total cost, we get 900 plus 130. That is 1030. Then next, 4 to 5 is over. 4 to 5, we can reduce only by 1 day. Then next, we can proceed further. It is introduced, since the cost is reducing 1050 and duration is also reducing. Since the cost is reducing, we need to proceed further until all these critical activities has to be crashed. As of now, we crashed the critical activity 3 to 4 by 4 days. That is 1, 2, 3, 4 days. On 4, 5, critical activity crashed by 1 day. We are crashed by 1 day. Here 1 to 3, we have to crash by 3 days. We will choose the critical activity 1 to 3. Is 1 to 3 in this path, 1, 3, 4, 5, and 4 to 5 is over. The possibility is only 1 to 4, and hence I chosen 1 to 4 by 1 day. Then in this path, 1 to 2, 2 to 4, and 4 to 5, 4 to 5 is over, because the maximum crash limit is 1 day. If you compare for 1 to 2 and 2 to 4, the cost of crashing for 2 to 4 is less. That is, we have 10 rupees in the given table, and hence I chosen 2 to 4 by 1 day. Then if you calculate, you will get 130 plus 25 into 1 plus 30 into 1. Then you will get the cost of crashing We get, then we will calculate current indirect cost. We get 840. Then total cost is given by 840 plus 195. We will get 1035. Here the total cost is increased from 1030 to 1035. Even though the normal duration is reduced, the cost is increasing. That indicates you need to stop the table at this junction. That means if you crash this activity 1 to 3, the total duration or the normal duration of the project will decrease, but the cost will increase. Since the cost is increased from 1030 to 1035, you need to stop the problem. The next, from the above table, the total cost for 14 days is rupees 1035, whereas for 15 days the total cost is rupees 1030. Therefore, the optimum cost compared to these two costs, 1035 and 1030, the minimum cost or the optimum cost is 1030 for 15 days. And hence, the project can be reduced from 20 days, that is from 20 days, that is the normal duration of the project is 20 days, to 15 days. It is the minimum project length. In the questions are given, you need to find the normal project length. Normal project length is 20 days. Minimum project length is 20 days with a total cost of rupees 1200 to 1030. To carry out a project for 20 days, you need to pay rupees of 1200. If you complete the project in 15 days by crashing those activities, we have to pay only 1030. And hence the difference between these 2200 and 1030, the rupees is 170. That means you can save the rupees of 170, as well as you can reduce 5 days. Instead of 20 days, you can reduce by 5 days. That means you can complete the project in 15 days with the cost of 1030. Or in other words, rupees 170 is saved. Let us go for the second problem in crashing. Determine the optimum project duration given in days and cost for the following data. They're given the activity, normal time, normal cost, crash time, crash cost. They're given, and they're given total 6 activities. It is from 1 to 2, 2 1 to 3, 2 to 4, 2 to 5, 3 to 4, and 4 to 5. And the given indirect cost is rupees 70 per day. Let us go for the solution. Since they're given the normal time, normal cost, crash time, crash cost, you need to calculate cost slope. To calculate cost slope, whatever the table they're given, you need to write the table as it is, where normal time is denoted by Tn. Cn represents normal cost. Tc represents crash time. Cc represents crash cost or cost of crashing. Here you have to write cost slope, that is said. To calculate cost slope, we have formula Cc minus Cn divided by Tn minus Tc. You know all the value Cc for the activity, say 1 to 2, you know the value of Cc, that is 200 minus 100 divided by 8 minus 6. Then you will get cost slope is 50. Similarly, for remaining activity, use this formula and calculate. We will get for 1 to 3, we will get 100. For 2 to 4, we will get 40. For 2 to 5, we will get 60. For 3 to 4, we will get 25. For 4 to 5, we will get 10. Then the problem, they're given normal time, normal cost, crash time, crash cost. You need to use this formula. You need to use this formula. You need to calculate cost slope for each activity. After calculating cost slope for each activity, you need to calculate normal cost of all activity. Normal cost is normal cost. It is summation of these values. That is 100 plus 150 plus 50 plus 100 plus 100 plus 80. That means we will get rupees 580. It is normal cost of all activity. The summation of all this, we get rupees 580. Then next, whatever the problems are given with respect to activity and the normal time, you need to copy down and you have to construct a network drawing. Since there is an activity between 1 and 2 and normal time is 8, that are represented by a node and a arrow mark. And similarly for 1 to 3, we have 4, 2 to 4, we have 2, and 2 to 5, we have 10, and 3 to 4, we have 5, and 4 to 5, we have 3. After completing the network drawing, we have to identify the path. In this network drawing, we have three paths. First path 1 to 2, 2 to 5 is 8 plus 10, it is we have 18 days. Next path we have 1 to 2, 2 to 4, 4 to 5. The second path is 8 plus 2, 8 plus 2 plus 3, we get 13 days. The next third path we have 1, 3, 4, 5. This 4 plus 5 plus 3, we get 12 days. Out of these three values, 18, 13, 12, the maximum duration is 18 days. And hence the path 1, 2, 5 will become critical path. And hence you have to show in a thick line or you have to show a double arrow mark that indicates out of these three paths, the critical path is 1, 2, 5 because the project duration is 18 days, that is maximum duration. Out of these values, whichever we have maximum value, that path we have to identify as critical path. After identifying critical path, we need to calculate a total cost. Normal cost of all activity plus indirect cost into project duration. Normal cost of all activity is given, that is 580 plus 70 into 18. Normal cost of all activity that given in the problem, the summation of all the activity of normal cost is 580 and indirect cost that given per day is 70. The project duration you got it as 18, then you have to write 18. Calculate, we get rupees 1840. Then next we have these three paths. There is 1, 2, 5, 1, 2, 4, 5, 1, 3, 4, 5. You have to construct this table. Here you write critical activity. Since the critical path is 1, 2, 5, we get only two activity. That is 1 to 2 and 2 to 5. Here you write 1 to 2, next 2 to 5. Then you have to write crash limit. Crash limit for the critical activity 1 to 2 is given by 2, it is 8 minus 6. They are given normal time and crash time. This 8 minus 6, they are given in the problem, in the question paper. They are given in the question, this 8 minus 6, it is normal time minus crash time. This 8 minus 6, we get 2 days. The next for 2 to 5, it is 5 days. It is 10 minus 5. It is normal time is 10. The crash time is 5. The difference you will get 5. These two values, it is 1 to 2, crash limit is 2. 2 to 5, the crash limit is 5. That indicates 1 to 2 we can reduce by 2 days. 2 to 5 we can reduce by 5 days. Cost of slope, you know, that is Z value for critical activity 1 to 2 it is 50 and 2 to 5 is 60. That is from the previous table. Then after writing the critical activity, you have to identify the least cost slope. Out of these two values, 50 and 60, the least cost slope is 50. Is for the critical activity correspond to this least cost slope. The critical activity is 1 to 2. 1 to 2. Therefore, the critical activity 1 to 2 you have to crash by 1 day. It is from 18 days to 17 days and so on. You have to construct this table. It is normal duration. Normal duration you have 18 days. Here you write 18. If it doesn't crash any of these activity, then you will get, if it doesn't crash any activity, crash activity, if it doesn't crash any activity, then you will get blank. Current indirect cost, the given, it is 70 rupees into 18 days. You will get 1260. Then total cost, you will get indirect cost is 1250 plus normal cost they given. Normal cost for each activity they given, it is 580. I get 1840 rupees. That means if it doesn't crush any of the activity, any of these activity, critical activity, for a project duration of 18 days, you have to pay rupees of 1840. Then next, if you reduce by 1 day, that is from 18 days to 17 days for the critical activity 1 to 2, because it is having a least cost flow. Is for 1 day. It is 1 to 2 for 1 day. You can reduce only for 2 days. Then cost of crushing is 50. It is 50. You have 50 for 1 to 2. You have 50. 50 into 1. You get 50 rupees. Current indirect cost, you are reduced to 17 days. And then here you write 17 into 70. 70 is indirect cost per day that given in the problem. Then you will get 1190. Then total cost we get 1190 plus normal cost for all the activities 580 plus 50. Then you will get 1820. That means we can complete the project. If you complete the project by 17 days, you have to pay a rupees of 1820, which is much lesser than this value. Since the cost is reducing and normal duration also reducing, we can proceed further because the cost is reducing from 1840 to 1820. It means 20 rupees is reduced, and then you can proceed further. Means you can crash the same activity 1 to 2 by 1 more day, because the crash limit is 2 days. It is from 17 to 16 days. If you crash the same activity 1 to 2 by 1 day, you get 50. It is the previous one 50 plus for this activity it is 50 into 1 day. We get 100. Here you write 16 into 70. You get 1120. Then we will get total cost 1120 plus 580 plus 100. You get 1800. That means the cost is reducing. That indicates we can proceed further. Here 1 to 2 crash limit is 2 days only. This 1 to 2 is over. This 1 to 2 is over. Only left out activity, critical activity is 2 to 5. And then for 15 days, you have to choose 2 to 5, because crashing activity or critical activity for 1 to 2, you have 2 days is reduced. Crash limit is only for 2 days. And then this activity is waived off. Then remaining critical activities 2 to 5, and you have to take 2 to 5 by 1 day. For 2 to 5, the cost is 60 rupees. Here you write 100. The previous value is 100. For 2 to 5, cost slope is 60. 60 you are reducing by 1 day. Here you write 1. 60 into 1 will get 160. Then since you reduced from 16 days to 15 days, here you write 15 into 70. We will get 1050. Then total cost we get 1050 plus 580. This is normal total normal cost plus 160. Then we will get 1790 rupees. That is, you have reduced the cost. Total cost is reducing by 10 days, 10 rupees. Since it is the cost is reducing, you have to proceed further, because 2 to 5 you can crash by 5 days. You already crashed 1 day, the remaining 4 days is left out. Then for 14 If you proceed in the same manner for 2 to 5, you are crashing for second day. 160 plus 60 into 1 will get 220. 14 days you are reducing it. 14 into 70 you get 980. Then total cost will get 980 plus normal cost is 580 plus 220. You get 1780. If the cost is reducing further, we can proceed further. That is for 13 days. 2 to 5, we are reducing for 3 days. The maximum limit is 5 days. Then you have 220, previous one, 220 plus. For 2 to 5, the cost slope is 60. 60 into 1 day you are reducing. It is 1 to 3, it is 1 day. 280. Then we will get an indirect cost. We will get 13 into 70, we will get 910. Then total cost, we will get 910 plus normal cost is 580 plus 280. We get 1770. This cost is reduced further. At normal duration, 13 days, if you check with respect to these three paths, we are reduced from 18 days to 13 days. At 13 days, there are two parallel critical paths. It is 1 to 5, which is earlier it is 18 days. We are reduced to 13 days. At 13 days, we have one more parallel critical path. It is 1, 2, 4, 5. And then in this, if you split this path 1 to 2, crashing is over. 2 to 4 and 4 to 5 is left out. There is no common activity between these two paths. There is you have 2 to 5 for in this path. You have 2 to 4 and 4 to 5. 1 to 2 is over already. 1 to 2, the maximum crash limit is 2 days. 1 to 2 is over already. Then next, if you reduce to 12 days in this path, that is from critical path 1 to 5, we can take the activity 2 to 5 because 1 to 2 is crashing this limit. Crash limit is already over. Is reached 2 to 5, we can reduce to 5 days. We already reduced to 3 days, we can go for 1 day. Then for parallel critical path, that is 1, 2, 4, 5. 1 to 2, crash limit is over. 2 to 4 and 4 to 5. If you check with respect to 2 to 4, 2 to 4, the cost slope is 40 rupees. Is for 2 to 4, the cost slope is 40 rupees. For 4 to 5, the cost slope is 10 rupees. Means the 4 to 5, the cost slope is 10 rupees, and hence you have chosen 4 to 5. That is for 1 day. For 4 to 5, we can crash by 2 days. Maximum limit is 2 days. Chosen for 4 to 5, if crash by 1 day, then we get 280 plus for 2 to 5. For 2 to 5, it is cost slope is 60. 60 into 1 day you are reducing, that is from 3 days to 4 days, is 1 day plus for 4 to 5, cost slope in the previous table. If you check with respect to 4 to 5, the cost slope for 4 to 5 is 10 rupees. 10 into 1 day, 10 into 1, we get 350. Then indirect cost will get 12 into 70 because you are reduced to 13 days to 12 days. 12 into 70 that equals 840. Then total cost you will get 840 plus normal cost is 580 plus 350. We get 1770. The cost is same, but the duration is reducing. That means that indicates you need to proceed further until the cost value has to increase or all critical activity the crash limit has to reach. Here if you look at the table for 2 to 5, the maximum crash limit is 5 days. That means you can reduce this 2 to 5 by one more day. At 12 days, if you check out with these three paths, all the paths, all three paths will become the parallel critical path. Out of these three paths, the common activity is 4 to 5, 4 to 5 for these two paths. For first path, you have 2 to 5 is left out and crash by one more day. Is you are reduced only for 4 days. limit is 5 days, and hence we can reduce by one more day because the cost is remain same, but duration is reduced. So reduce by one day, that is for 2 to 5, we can reduce by 5 days. Maximum limit is 5. This from 4 to 5, that is one day you are reducing it. 4 to 5, because if you compare these two path at 12 days, this 13 days is earlier you reduce to 12 days, and these three paths will have a duration of 12 days. At these two for these two paths, there is a common activity is 4 to 5, 4 to 5, and hence I have taken 4 to 5. The maximum limit is 2 days. You can reduce for 2 days. Already you are reduced for one day. You can reduce one more day. Then if you calculate, you will get calculator will get 350 is previous value plus for 2 to 5 cost slope is 60, here you write 60. For 4 to 5 cost slope is 10 into 1 day, it is 1 minus 2, it is 1 day, it is 450, 420 rupees. Then current indirect cost will get 11 into 70, it is 11 days, into indirect cost is 70, you will get 770. The total cost calculate will get 770 plus 580, that is the normal duration cost plus 420. Then you will get 1770. That is the cost remain same, and for the normal duration 11 days. Here if you check out these values, 1 to 2 crash limit is 2 days. 2 days is over. 1 plus 1, 2 days. For 2 to 5, for 2 to 5 is 5 days. It is 2 to 5. You are reduced for 1 day, 2, 3, 4, 5. That means for the critical path 1 to 5, for the critical path 1 to 5, crashing limit crashing limit is reached. That means you need to stop the table further, and then from the above table, the critical activity 1 to 2, 2 to 5 are crashed to its maximum crash limit. That is, for 1 to 2, the maximum crash limit is 2 days. We crashed 2 to 5, we crashed for 5 days. Therefore, further crashing is not possible. Hence, the optimum project duration is 11 days, and optimum cost is rupees 1770. That means the project will complete for 11 days to an optimum cost of 1770.